We're going to be talking about the domain and range of both a continuous and discrete graph. I want you to take a quick second. What does it mean to be a continuous graph, and what about a discrete graph? Alright, well, continuous, meaning you can trace the whole graph without picking up your pencil, right? Something like this. Discrete, remember discrete, connected, where you have to pick up your pencil to trace the graph. We're going to have to write out some compound inequalities here to express either the domain or range in some situations. I'm going to go over the first 5 graphs, and then you are going to complete the last 5 graphs. I'm going to highlight the domain in yellow, range in pink. Let's start with the domain first. All right. So the domain, again, your x values that you're using. Look at the points right here. Identify what x values you're using, and then play the video. All right, so these points right here, we're using this x value, this one, this one, this one, this one, this one. Okay, so let's identify those values. We got, we're gonna be listing them. What do we got? -9, -4, 0, 4, 6, and 8. Now for our range, I'm gonna highlight this in pink. Identify the y values that you're using, then play the video. All right, now our range, our y values that we're using, we're looking across right here. So this point is down 5. It's kind of hard to see that y-axis, so find that arrow right here, draw a line straight down. There we go. Arrow right here, draw a line straight across. There we go. Now it's easier to just see your axis now. So this point right here has a y value of -5, 0, 3, 5 for both those points, and then 7. Alright, so what did we say? We said -5, 0, 3, 5, and 7. So if it's a discrete graph like this, you might have a scatter plot, so you might have where you're just listing out those numbers. Alright, next one here. Our domain. Alright, I want you to try and see what x values are we using here. Well, if we're starting at the left-hand side, we're using all the way from here, all the way over to that x value at that point, right? So we're going to stop right here. Let's look at what our min and our max here are. Well, our minimum x value is right here, our maximum is right here. So 1, 2, 3, 4, 5, 6, 7, -7 is our min. And then our max is 1, 2, 3, 4, 5. Okay, pay attention to whether you're including the point or not. Here, we're including the point, right? Here, it is an open circle. We're not including the point. So if our x values are between these two values and we're using less than or equal to or less than, this is less than or equal to, this is just less than because we're not including that point. It's open circle. So we're going to put our x in the middle. All right, our minimum, -7, less than or equal to, maximum is 0, less than. Our range. Our range is the set of y values that we're using. So we're looking up and down now vertically. So if we're looking at our lowest point right here, our y value looks like, what do we say? That is -3. Okay, and this is a continuous line, right? So we are using every single y value. We compare y value right here to a point on the graph here, 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 all the way up to the y value of 1. So we have 1, 2, 3. -3 is our min. We're including that point. So less than or equal to our max. We're not including that point. So it's just going to be less than. So our range is going from -3 to +1. All right, our domain for our next graph, I want you to try and identify the domain, write it out as compound inequality, and play the video. All right, so if we're looking at our domain, if we're going all the way to the left right here, our minimum x value is going to be 0, and we compare any x value from here to a point on the graph. Our minimum x value is 0. We're including that point, so less than or equal to. Our max value is 1, 2, 3, 4. We're including that point, so less than or equal to. So we have x is greater than or equal to 0, but also less than or equal to 4. All right, I want you to identify the range and play the video. All right, so our range is going all the way from this point right here, so y value of 0, all the way up to this point right here, y value of 1, 2, 3, 4, 5, 6. So we have 0, and then 1, 2, 3, 4, 5, is that 6? 1, 2, 3, 4, 5, 6, yep. And we're including each of those points. So 0 to +6. All right, I'm going to flip this guy over here, and we got 2 more to do. Notice we're kind of doing a bunch of different types of graphs, so you get some good practice. Again, I want you to try to identify, this is going to be different now. Notice your arrows on your graph, meaning your graph is going up and out both ways forever. It is not stopping. So what do you think your x values are going to be there? What x values are in our domain? Every single x value, because we have 0 paired with this point, 1 paired with that point, 2 paired with this point, 3 paired with that point, and then we have 3, 4, 5, 6, 7, 8 is eventually going to be paired with a point out here because it's going to go up and up and up and out forever. Same with the left-hand side. So your domain here is all real numbers. And the symbol for all real numbers is an R with a double trunk. So if you ever see the R with a double trunk, it means all real numbers. So I'm just going to highlight the whole axis here with arrows showing we're using every single x value. Now we could be using a half too, not just whole numbers. So like a half, 1.5, 2.5. So decimals are included there in all real numbers. Your range is your y values, right? So what's our smallest y value? Well, 0 right here, right? And then if we're going up, we compare y value with a point on the graph going up and up and up here. Well, eventually our graph is going to keep going up and up and up and up, right? So we'll be able to keep pairing each y value above 0 with a point on the graph. So technically our minimum y value right here is 0, and we don't really have a max, right? Our maximum is infinity, so technically all of our y values are greater than or equal to 0. As long as it's bigger or equal to 0, a point on the graph has that y value somewhere. All right, and then our last one right here. Try and identify the domain and the range, and play the video when you're done. All right, our domain. Well, this is kind of an odd graph, right? Well, our domain, our min is all the way to the left, our max is to the right, right? So what's the farthest most left point? Well, right here. Okay, so that's where our x minimum is. What's the farthest most right point? Well, right here. Okay, so we're using all those x values in between there. Well, that's kind of hard to see. So we're going from here to here. So that's negative 1, 2, 3 is our min, and we're including that point, so less than or equal to. Our max is 1. We're including that point right here, so less than or equal to. Our domain, negative 3 to positive 1. All right, our range. How far up and down, right? What's our lowest point? Well, right here, right? So we're using all of our y values from here all the way up to our highest point. Let's identify that min and the max. So our min right here, 1, 2, 3, 4, 5, 6, 7, negative 7 is our min, and we're including that point, so less than or equal to. And then our max is, looks like 2. 1, 2. And we're including that point, so it's less than or equal to. Alrighty. Now the next problems are similar to one that we may have already done. So if we need kind of a refresher, look back at a previous one we've done. So like for example, this one is very similar to number 1. All right. Your second one here is really similar to the second one that we did. All right, so make sure you are attempting all the rest of these, so you have 5 more to do.